Hello everyone, hope you are doing well. So today we are going to talk about RT-PCR. You must have heard this term countless times in past year. Now what is RT-PCR? So the RT part stands for reverse transcription, whereas the PCR stands for polymerase chain reaction. So these are two separate concepts which are joined together to give this RT-PCR test for COVID. Okay, as you can see here, a lab technician is collecting sample from a person's nose. So this is known as a nasal swab. So let's say he collected X amount of DNA sequence. Now this X amount is not enough. It's not sufficient to determine if the person is negative or positive. And if the sample is not enough, maybe the test comes as negative and then the person is at risk himself as well as to others. Hence, we need to increase the number of DNA sequence we have. Now, we cannot collect more DNA sequences from this person. That would be uncomfortable and maybe not possible because, say, the virus is an initial stage and it hasn't really created as many copies of itself. So this is where the PCR comes, the polymerase chain reaction. So what PCR does, it increases the number of DNA sequence. So let's say we started with 10. PCR runs in cycle. Okay, so after one PCR cycle, if it's 100% efficient, we'll have 20 DNA sequence from 10. Okay, and then after another cycle, we'll have 40 and then 80. So at 100% efficiency, the number of sequences doubles itself. Okay, so let's say this was your initial sample collected in the nasal swab. Let's say this was not enough to determine if a person has COVID or not. You run a few PCR cycles and you reach here. Again, let's say this was not enough either. Say we run 6 cycles here. And then we run another 5 cycles and we reach here. And this is where we reach a detectable level of viral load. So we will say after 11 cycles, the viral load was enough to determine if a person has COVID or not. So this cycle, this is what when you read a person's RT-PCR report, there's a CT value written there. CT stands for cycle threshold. So in this case, CT would be 11. So after 11 cycles, this person has, we have synthesized enough viral load that this person we can safely say this person has COVID. So as per the ICMR, the magic number is 35. That is, if within 35 PCR cycles, if the sample reaches this detectable level, then we'll say the person is positive. And if despite doing 35 cycles, we still don't reach this level, the person would be negative. So basically, a higher CT number is better. Again, I'll explain how. Let's say from a person we extract 10 DNA sequence, okay? And let's say the threshold is 500. So after the first cycle, we'll have 20. After second, 40, 80, 160, 320, 640. How many cycles did we need? 1, 2, 3, 4, 5, 6. So after 6 cycles, we have crossed this threshold limit of 500. Now let's say another person has a viral load of 100 in the initial sample. How many PCR cycles do we need? 100, 200, 400, 800. So we need only 1, 2, 3 cycles. So that's why a higher cycle, it means that you have less viral load in the initial sample and thus you have less virus present inside you. Now earlier it was said a viral load over 24 is very, very, very less infectious compared to viral load over less than 24. So this was another threshold that was going on around, that if your CT number is above 24, you are less infectious and thus you are less likely to infect other people. And if it's less than 24, the likelihood is higher. And to test negative, like I said, the magic number is 35 CTs. So if After 35 CTs, you still haven't reached a detectable level, you are COVID negative. Now, the one biggest problem with PCR test is that it is very sensitive. So even if you have, say, dead COVID virus inside you, or say you have, like, you are almost healthy, but you still have 1 or 2 viral loads somewhere. So that also might give you a false positive. But, prevention is better than cure. So it's more likely if you have COVID, like, it's better if you take care and others also take care around you, than, let's say, if you are negative and yet people take care, and to be on the safer side. Now, it's not like PCR was developed for COVID. The technology has many other applications as well. So one application is studying fossil DNAs. So let's say we have this mummy. Now, this mummy only has 20 DNA sequence left on it. It's not enough to study about its origin and the differences between us and them. So we run a few PCR cycles. Let's say we run 10 or 20 cycles, and we suddenly have 1 million DNA samples. This was one application of PCR. The second is in forensic analysis. So let's say there has been a crime and you extract DNA sample of the perpetrator. Now, the amount of DNA sequence extracted is very less. So again, you can use PCR to increase the number of DNA sequences, and you'll have enough DNA to run your test on the sample. And the third application is medical, such as during infectious diseases or study various viruses. So again, like, this is self-explanatory, as testing for corona is one of its application now. But we are talking about PCR. But the test is named RT-PCR. Why is that? So COVID-19, it is not a DNA virus. It is an RNA virus. So and PCR test does not run on RNAs. So through the process of reverse transcription, using the enzyme reverse transcriptase, we convert this RNA into DNA, and then we can run our PCR test. And that's why this complete test for COVID is called RT-PCR. So the RT stands for the process where you convert the RNA into DNA. This DNA is called cDNA, also complementary DNA. And PCR stands for the number of cycles you run to increase the DNA sequence you have with you. And that's why it's called RT-PCR. Now, 2 other major tests for COVID are antigen testing. So this, you can assume, is the same as PCR test, but there's no cycle to enhance the sequence. So you just collect the nasal swab and you check it. If the viral load is above the threshold, you are positive. If it's below the threshold, you are negative. And that's why antigen testing is not very accurate, because even with low viral load, a person can be positive. Like, maybe they are diagnosed in the initial stages when they have less viral load. And hence, antigen test is not advised, and we always go for RT-PCR to confirm if someone has COVID or not. So if you come positive in antigen, it's more likely you have COVID, but if you come negative, you should get RT-PCR done. So antigen, it detects the virus proteins in the bodies. Now, antibody test, this is another test, but here, instead of nasal swab, we collect blood samples. So what it does is, it detects for COVID antibodies in the blood. So if someone has been infected, the immune response will be to secrete COVID antibodies. So in antibody test, we try to find these antibodies. So this test is not exactly a test to determine if you're positive or not. Definitely it can help, but this test is mostly to know if you have already been infected with it in past 1 or 2 months. So this is also used in sero surveys. You must have heard about sero surveys. So it was done to determine how much population has been infected. So let's say you've been infected with COVID, 2 months ago, you will still have some antibodies inside your body, and thus your antibody test will come positive, and that will tell the authorities that yes, this much population has been infected with COVID. Okay, I hope this was clear. Thank you and have a good day.